Okay, so I had hoped to get this done last week, but for a variety of circumstances that did not happen. What I did do last week was plan it out because we have reached the part of chapter 7 where the only thing remaining for us is a couple of sections about word problems. And so I wanted to scope them out ahead of time. And as I scoped them out ahead of time and decided what to keep and what to discard, I also ran into some issues with some of the word problems where I was struggling to get the answer, or an answer, I should say, which is perhaps not a good sign. Maybe it's just a signal of how fuzzy and distracted my brain is right now. But regardless, it needed some thought and some work. And so I am plunging ahead now with the selections that I settled on last week, and hopefully these are good ones and not confusing ones. It's always hard. They throw too many word problems at us in these sections. And so I'm going to try and just strike a nice balance and give you things that are actually semi-easy to understand, and maybe some things that tie into word problems that we've seen in the past. That tends to be my theory here. So as you can see, only examples 1, 3, and 5 are important from section 7.6, in my humble opinion. And to teach the material that's covered in example 1, I'll be doing practice 1 and then some extra problems from the back of the book, because just one problem is not enough. Example 3, I'll show you practice 3, and then I'm going to specifically highlight number 24 from the homework section. And then from example 5, this is where it gets weird. No practice 5. Practice 5 to this moment, I've been able to solve all the other problems that are covered by the example 5 material. Practice 5 never came to me. My theory, having worked all those other problems, is that there's a piece of information missing. And I have a theory as to what it is. And I would just say, for your own benefit, there's plenty of other good problems for us to look at. We'll do a couple of those. So without further ado, practice problem number 1. This is page 418. Okay, so they start us off very basic. If you remember in 7.5, what we were doing was solving equations that contained these rational expressions we've been talking about. Same thing here. It's just that we don't get quite as satisfying of an answer now, because we're going to have something like this. And they're going to say solve, but specifically they're going to want us to solve for a specific letter that's contained in that problem. So not just solve it. You don't want to just solve down and get x equals 5. You're going to solve for a, and what that means is to isolate a. And in algebra, typically the way it works, if we have 3 variables, we would need 3 separate equations to be able to solve down to where we knew what number each variable represented. If we only have 1 equation and 3 variables, we're not going to be able to get like a equals 5. But what we can do is rearrange so that we know, so that we get the equation rather in a better form, so that we get a equals and then stuff. Basically everything else. That's our goal in the problem. So what we do is very similar to what we were doing in 7.5. So what we need to do is establish our least common denominator. Okay, just like we were doing last class, even though the result will be less satisfying, I apologize for that, but it will. We need an LCD. So basically the LCD between A, B, and C, the only expression that encompasses all 3 of those quantities is actually A times B times C. So what we're going to do is, as we would have done last class, last recording, we want to multiply through by our LCD, because multiplying through by the LCD always cancels out any individual denominator. That's what the LCD is made to do. Okay, so here we go. Times ABC times ABC times ABC. And in each case, if you notice, if I can be strategic about my canceling and not destroy too much, the A's cancel on in the first term, the B's cancel in the second term, the C's cancel in the third term. And so what we're left with is BC minus AC equals AB. So no more fractions, always a good sign when we start out dealing with rational equations. It's great when we get to that point where there's no fractions. The next step that we need to complete, excuse me, we need to collect all the terms that contain A on one side of the equation. And if it's me talking, of course, that's going to be the left side. I eventually want to end up with my letter, the letter that they have chosen for me. I want to end up with that on the left side, everything else on the right. So I can leave the minus AC right where it is, and maybe subtract this AB to the left so that it's together with that AC. And then BC is just in the way right now. I'm going to subtract that over as well. Now, there's some funny tricks I could have used to get to this point and have no more negatives, but I'm just gonna roll with this right now. What we need to do is to now factor out minus A as a GCF. This is a chapter 6 technique that we don't always have to do. Excuse me. When did I start talking? It's like asking for a frog in my throat. A is basically our GCF, but remember that if the lead term in your expression is negative, that has to come out as part of the GCF as well. Unfortunately for us, perhaps it does add to our workload. So we're going to factor out a negative A, have some leftovers. The reason we have to use this technique is because AC and AB are not like terms. They can't be combined together nicely. So the only thing left for us is some factoring. When we pull out the negative A, what we're going to have is a positive C. This negative in the middle got pulled out as well. So now we have a plus and we have a B. Okay, now at this stage, I would just encourage, notice that you have the left side negative and the right side negative. When that occurs, you might as well cancel those. Just cancel out your negative from the left and your negative from the right. So I'm gonna kind of use dotted lines here so it doesn't look like I'm destroying too much of this problem. And then you have positive A times C plus B equals positive BC. Not too bad. The last step towards isolating A is literally just to divide away that C plus B quantity from both sides of the equation. Now this would be super easy. Like if we had 2A equals BC at this point, I don't think any of us would stumble over the fact that we have to divide out that 2. It just gets weird when the quantity that's next to A is not a nice little number like 2, it's C plus B. But the principle stays the same. The algebraic principle stays the same. So we get A equals BC. And here in the bottom, C plus B can be released from their parentheses. Those become unnecessary at that stage in the problem. So here's some canceling. That's what we get left. Okay, so that we have accomplished the goal. Problem told us we were to isolate A, solve for A. Let's do a few more of those. So I'm going to dip back into the homework section and pull up number 1 on page 423. And these equations are kind of cool because they're real equations. They're not made up for the purposes of forcing us to learn a technique. This particular equation, if you look in the book, they tell you it's from meteorology. And looking at it, science not always my strong suit, but I'm pretty sure this is the Fahrenheit to Celsius, or Celsius to Fahrenheit, I should say, conversion equation. Not sure about that, but it's been a while since I've done those. So we want to solve for C. We want to isolate C. Here it is, stuck to this 9/5. And just as a hint, anytime your variable of choice is stuck by multiplication to a number or to another letter, usually it's going to be the last thing you do to unstick that. You're going to move everything else around first, and then you'll unstick that later. So what we can do, I have so many options. Wheels are turning here. What we can do, kind of like what we did in the previous problem, let's collect any term that has C in it on the left, because we want to end up with C on the left. So that's going to require us to subtract. We can leave the F there. Let's subtract 9/5 C. So now all we've got on the right is the number 32. Now that F is in the way. So I'm going to leave my negative 9/5 C, leave my 32, but I'll subtract the F over to be with it, okay? There's ways I could get around some of these negatives, but I'm choosing to just err on the side of possibly less efficient, but more consistent, just for teaching's sake. Okay, now what I'm going to do here, anytime you have a fraction, and of course you wanna like divide that fraction away. So in a sense, what you wanna do is this to both sides. But we've talked enough about dividing by a fraction that I think maybe we're safe to go ahead and recognize that dividing by a fraction is just multiplying by its reciprocal. So let me go times negative 5/9 times negative 5/9. And gotta be careful here. That's negative 5/9 times the entire little subtraction problem, 32 minus F. So another situation where I have to remember to introduce the parentheses myself. The problem won't do it for me. Okay, so having two reciprocals multiplying each other will cancel them out and very nicely reveal our C as the only thing on the left side. Now, it's up to me. I'm going to scramble some things around here. Let me keep 32 minus F in parentheses. I'm going to pull this negative 5 right here, put that 9 under it. And I am just curious because I could play with this all day, but I want to know where the book leaves off, because I know that this is an odd numbered problem, and this would be something that we would all run to the back of the book eventually and check. Yeah, okay. All they do, I'm going to say this is okay. This is fine mathematically, but the book takes it a little bit farther. They don't like having a negative out front, so they multiply it through. So what you get from them is 5 times positive F negative 32 over 9. as they, you know, and if you think about a middle step, if you multiply that negative through, you get 5, negative 32 plus f over 9. And then they choose to just roll those around because they can, it's addition. And they get this. So middle step. Is that productive? Not really, but just because this is a real formula that's used in meteorology, it's good to know how they get to what they get, because you might run into this in a science class. So, okay, number 3. This is from the world of finance. So we want to solve this equation for capital I. So we've got Q, capital Q, equals capital A minus capital I all over capital L. Okay, so here's this I. This is the thing that we want to have isolated on the left-hand side, but it's not going to be as simple as just adding or subtracting it over like we've been doing. What we need to do is acknowledge the fact that it's part of a fraction. The first thing that we have to do is get rid of that fraction by multiplying both sides by L. I don't know if it matters whether I put L on the left or the right, so I'm just going to go with what I've done here. So LQ equals A minus I. No more L's, those nicely canceled out, which I can do in the green again if you'd like. There they go. Okay. Now comes the time where everything's in a straight line, no more fractions. And sure, I need to solve for I. Let me add it to both sides. So currently I have an LQ over there. Now I'm going to have an LQ plus I. That leaves the A, very sloppy A, over on the right. And thankfully in this problem, the only thing I have to do to isolate I completely is just take what used to be a plus, a positive LQ, and on the other side, it will become a negative LQ. And since that one's easier than some of the ones we've done previously, kind of nice. Okay. Flipping along here, I think I picked one more. They're so good. All these problems are so good. But I wanted to hit some different categories just so that you've been exposed to those before you attempt problems on your own. Solve for, not 2. Solve for lowercase a. So this is capital S equals lowercase n, lowercase a plus L over 2. This is something from the world of pre-calculus. So this isn't too far maybe in some of your futures. Want to solve for A, there it is. It's just trapped in the middle of a bunch of junk. So we can't focus on A immediately. Instead, we have to do kind of like we did a minute ago, multiplying both sides by the denominator of 2 here. We had a denominator of L a minute ago. Okay. So that is going to achieve the goal of canceling out the 2's. And we'll have 2s equals n times a plus capital L. Everything's in a straight line now, no more fractions. Unfortunately, though, a is trapped in this set of parentheses behind the n. So I think what I would do next is actually distribute that n. So I've got 2 capital S on the left, and I'm going to have n times little a plus n times L. And now I've got a term that can be subtracted over to the other side. So in the next step, that 2 capital S will now be 2 capital S minus NA equals NL. Past that point, I recognize that my 2 capital S is in the way. So I leave my negative little n little a. And okay, that's great. I've got that. It's like the 2s just kind of came over here, became negative. And in the final step, I want to divide away everything that is not a from this term on the left. So that's going to be the negative sign and the little n. Negative sign and a little n. Okay, now this is not an odd numbered problem, so I can't check and see the way the book does this, but I suspect that they would not be enamored of that negative a or negative n in the denominator. So what I'm guessing would happen is the n would become positive and the negative would come up top and run through this expression here, like negative NL positive 2s. Or I further suspect, based on what they did in the meteorology problem, that maybe they'd shift around the 2s and the NL like that. Any of those are acceptable in my book. If you were like turning this into me, any of those would be acceptable. Just know that they may not show up if you get the opportunity to check in the book. And I was trying to remember what formula from pre-calc this is. I feel like they use different variables from the ones in my pre-calc book. So I'm not 100% sure even how pre-calc would want this because I don't know what all those letters mean. Yeah. That's always fun when different books opt for different ways of describing the same thing. But know that the formulas in pre-calc are made to be used. So I feel like whichever one of these 3 options seems the most user-friendly to me, I do like this one because the one negative that lingers is in a very, to me, user-friendly position. So just from experience, that's the one I prefer. Now, so we had 3 categories of word problems. That was the example 1 category. We're going to move on to the example 3 category, which I don't hit as hard if you notice. And it's mostly because example 3 techniques end up cropping up in the example 5 material. So we will get example 3 techniques, fear not. Okay, so practice problem 3 on page 420. And this is where things start feeling like a true word problem. Okay, so this or these 2 problems that I'm going to work are examples of proportion word problems. Okay, and a proportion, just before we even dive into that, is 2 ratios set equal to each other. And I would further remind you, just kind of peeling back the layers of this onion, ratios are basically fractions. Fractions we set up to express relationships in word problems. And you'll see what I mean in a minute. So I don't want to just flat out say fractions. I want to be a little bit more descriptive. Okay. But basically, you're going to have a fraction, I don't know, 1/2 equal to another fraction, but you won't know both parts of the other fraction. So just a little quick preview of what proportion word problems entail. All right, so now that we've gotten to the true word problems, unfortunately, that means I have to put some words on the page here. So selecting only the words that are really important. So in the US, 1 out of every 12 homes is heated by fuel oil, they call it. And it's nice they have a source down there. A lot of this information should be true. Okay, so at this rate, and I guess that's important to put because that indicates what was true in the first sentence is going to hold true in the other sentence. At this rate, how many homes, if you have a community of 36,000, how many of those 36,000 homes are going to be heated by fuel oil? Okay, but remember, you can't touch anything, okay? Gotta be quiet, you can't touch anything. If you want to bring your drawing, you can draw over there, though. Okay, so what I usually do, 1 out of 12, that's just a fancy way of saying 1/12. So I just write 1/12 equals because that is my first ratio. And I know this is a proportion problem, so I need 2 ratios set equal. So at this rate, how many homes out of 36,000 are heated by fuel oil? So it's like, I don't know, out of 36,000. So I've got something like that. Careful, Matthew, you're kind of in my way, babe. I have to move you over here. So I've got room for my arm. There we go. And because this is algebra, the question mark is fine, but I usually use, and they do as well, X over 36,000. Okay, now this is probably the first time we've had to solve a proportion. The long way, because this is in the section about solving rational equations, the long way would be to find the LCD and to multiply through by it. So the LCD here is actually 36,000 because 12 divides into 36. So 12 definitely divides into 36,000. So you can take your LCD, both sides, to cancel. Well, you can. So cancel 36,000s, and then the 12 will just divide into that, get a 3,000. And what you'll have is 3,000 equals X, or X. Be careful, that's my color. Or X equals 3,000, and that would be 3,000. What's mine? Okay, so we get 3,000 homes. So instead of, okay, your pants off and go ahead and go. Instead of using LCD, we often use another technique when we're dealing with, and I'm going to go ahead and call it a shortcut. I think it does amount to a shortcut. Proportion problems. And that shortcut is called cross multiplication. Very descriptive title, as it turns out. Okay, so here's what that would look like here. We had 1 over 12 equals X over 36,000. So the shortcut is this. You can multiply in a cross shape, X times 12. So I'm going to say multiply. And then you can multiply to complete the cross 1 times X times 12. You can multiply 1 times 36,000. So 1 times 36,000 is 36,000. And X times 12 is 12X. And You can, if you want, because I'm always wanting that X on the left, you can subtract to see the term containing the X on the left, and then just divide like that. Cancel your negative 12s and you will get 3,000 homes. You'll get the same thing. So it's just a really quick thing. Instead of having to even pause and think about the LCD, you dive right into multiplying in that cross shape, and you can get on with solving your equation, I would say, a lot quicker. So I only wanted to do one more of those. That'll be a while. Okay, you need to go play or something. Page 423. So diving into the homework section. So a camel, technically an Arabian camel, but I'm choosing to. Okay. I'm choosing to leave out the word Arabian because I don't think that helps the math one bit. Okay, so a camel can travel 20 miles in 8 hours. And I am going to include this information so we can talk about why it's there. Carrying a 300-pound load. So once again, at this rate, how far can the camel go in 10 hours? Okay. Now, if you start reading this, a lot of times you can start setting stuff up. I know it's not good practice with, or the way we're supposed to do things with word problems, to start setting things up while you're still reading, but technically you're like 20 miles in 8 hours, like 20 miles in 8 hours equals like that. And then you hit this 300-pound load. And that's kind of like, okay, where do I put that? I had miles, hours. Good to have the miles and the hours there. You can kind of see that's a mile per hour setup that we've used in the past. Not sure where to put the 300 pounds, so we keep reading. So at this rate, how far? So that the question mark is going to go with respect to miles. How far can the camel go in 10 hours? We've set up a complete proportion that we can solve out. That 300 pounds went nowhere. It turns out that is an extra number to confuse us. That's all it is. So we're on to them. We see what kind of game they're playing here. So 20 over 8 equals x over 10. I am going to divide. I am going to multiply here. I'm going to multiply here. So perform that cross multiplication with the orange. 8 times x, that's 8x. With the 20 times 10, that's 200. And then very simply, to isolate x, divide by 8, divide by 8, x equals 208. 8 might go into that. 8, 16, yeah, 25. 8 goes into 20 twice with a remainder of 4. 8 goes into 45 times. Checking myself there. So 25, and we were talking about miles. How many miles? So proportions, honestly, I like them. They're nice. They're a nice little break in the middle of word problems because they're pretty quick to set up. Now, I'm hoping I've left myself time here because the third, final, and nasty category of problem, I'm going to put that this was a proportion word problem. The last category, once again, we would ordinarily hop right into practice problem 5 because that's the material I'm trying to cover. But practice problem 5, if you look at it, and you're welcome to look at it, they keep talking about an airplane flying from Los Angeles to Boston and another one flying from Boston to LA. In my professional opinion, what they needed to have given us to complete the problem was the actual distance from LA to Boston. I was able to work all these other problems that are in this sort of segment, except that one. So their example problem, the homework problems, everything was working out great, a little bit difficult, but it was working out. Practice 5 was just not working out for me. So we're going to, let's see. Did I even tell you guys? Yeah, only extra problems. Okay, so these are distance equals rate times time problems. And that's why I picked them, because we've done them a couple of times in the past. They just keep changing. The framework keeps changing. I think what I decided to do was work number 32 and 34 for you, so that 31 and 33, if you want to use those as practice, go for it. Okay, so number 32, and I've got hopefully my cheat sheet here of when I worked this out. Okay, so have to write out a little bit of a framework, a plane and a truck. They tell you what kind of plane and what kind of truck. I don't care. Leave the same town at sunrise. So basically you can say to yourself, they leave the same location at the same time. And head for another town. And that other town is 450 miles away. Okay, so pretty simple so far. You've got plane and a truck, one on the ground, one up in the air, and they want to get, their goal is to get the exact same distance. And if I were a better drawer, there's my plane. There is my truck. The plane looks tiny compared to the truck, but that's because it's up in the air, right? Okay, so now we get into rates. So the speed of the plane is 3 times the speed, which I'm going to just say that, of the truck. So the plane's going 3 times faster than the truck. I'm going to break this sentence up. The plane arrives, so it covers that 450 miles 6 hours faster . And our goal in this exercise is to find the truck's speed. Now, what the book does, and what I kind of like, is they set up a little bit of a grid. So we want distance equals rate times time. And I'm breaking this apart, spreading it out on purpose here. This is the type of thing we're after. Oops, I'm gonna see where to draw my, line, and then we've got 2 things going on here. Which one do they mention first? Because I literally go with the first thing my my eyes light upon is a plane, so I'm going to put that first. And then the second thing is the truck. Okay, now I know that the distance for both the plane and the truck has to be 450 miles. Okay. 450, 450, and then equals. And then I've got rate times time. Now, the secret to all of this, the speed of the plane, let me underline that in orange, is 3 times the speed of the truck. I don't want to use the word speed. I want to use the rate, the word rate. So rate of the plane is 3 times the rate of the truck. So if the truck was going 90 miles an hour, the plane would be going 270 and so on. And then the time, there's a little bit of the time of the plane is 6 hours ahead of the truck, 6 hours less, you could say. So however long it takes the truck minus 6. So we have a couple of equations here. So the rate of the plane is just the rate of the plane times the time of the plane. Okay, this is the P equation. So you know me, if you've watched enough of these or been in enough of my classes, I always like the little subscripts to keep my different planes, trains, and automobiles separated from each other. Okay, now just for continuity here, the truck would technically be rate of truck times time of truck, but we know that yeah. Let me stop talking for a second, make sure I've got that underlined. Okay, so rate of plane, time of plane, rate of truck, time of truck, but let me go back here. The RP and the TP can very naturally be replaced. That's what I needed to be doing. So after you see kind of where I'm headed here, the RP, I think I was about to work this backwards. RP is 3 times RT, so I can go ahead and make that substitution. And TP is okay, so I think unhelpfully what had happened to me here is, yeah, the color coding was maybe not helpful. So I feel like if I was really good, I would back this recording up and go back over that and make my color coding kind of match here, because I think what I was trying to do is make the rate column be orange and the time column be green. So the time that the plane takes is the time of the truck minus 6. That, and then let me go ahead and make this one orange. That's what I did not practice on my sheet off to the side, was color coding. I should have borrowed some of Matthew's colored pencils. Okay, so sorry about that. So distance equals rate times time. We have a plane row, 450 equals rate times time for the plane. And the rate of the plane could be rephrased in terms of the truck, and the time of the plane could be rephrased in terms of the time of the truck. And then the truck down here is just as it is. So let me take what I've got. I've got for the plane, 450 equals 3 times the rate, and then the time minus 6. In terms of the truck, I've just got the original. Okay, now, here's where an option, a choice arises. What they want out of me is the speed of the truck. RT. So my options here, it's actually easier for me to go about this in a little bit of a roundabout way. And I'm trying to decide, is that going to totally throw everybody off? And I think it will. So if my goal is to find RT, what I'm going to do in each equation is I'm actually going to isolate RT in each equation. Yeah, good job. In a minute, Matthew, you can find some clothes. He's still in his PJs. In a minute, we'll need to find you some clothes. Well, in a few minutes. Okay. Probably about 10 more minutes, okay? No, it'll be about 10. Okay. So if I find RT, so I want to isolate that RT in both equations. Both 1 and 2, I need to isolate RT. Okay, so what I can do here, so many options. Anything that is not RT, I can divide it away in order that I can cancel some 3s. Okay, so I've got 450 over 3 times T. Do they? Interesting. Equals RT. Now, this is a case where, because everything was so messy, it was actually easier for me to get RT on the right. But I can rephrase that. X equals 2 is the same thing as 2 equals X. Okay, so I've got RT isolated here. And then over here, it's just a simple matter of that. Now I've got 2 RT equations, so I want to set them equal. Okay, so I set them equal. So RT equals itself, so I could say that this RT and you notice when I set them equal, the RTs disappeared. That's okay. I still have 2 nice equations for RT here. I'll get back to that. This is just the simplest way. And according to what we learned or what we've been learning, cross multiply. So I'm going to have 450 times T equals 450 times this 3 T minus 6, okay? A 450 on each side is kind of nice. They will divide away, cancel away, which I'm not even showing because it's probably the simplest part of this problem. Okay, I want to multiply through my 3. 3 TT minus 18. The only letter or variable left is TT, so I want to get the TTs over to the left. Again, me just being obsessed with going left all the time, which to you guys on the recording probably looks like going right. This is a -2, -18. So the time that the truck takes is 9 hours. What, Matthew? Oh, that's an ad. I thought it was a nice song on Pandora and it was really an advertisement. So 9 hours, they were actually asking about the rate of the truck, not the time of the truck. But this is what happens when, okay, so R of T, this is one of the weird things about proportion problems. Because you have two separate things that you're setting equal, you know you're after R of T. When you isolate R of T in both, it's actually going to disappear, but that's okay because we know that we have a couple of really nice equations here. So 450 over T of T is probably the nicest. So I'm going to come all the way down here. 450 divided by that 9. Okay. So the rate of the truck, 9 times 5 is 45. So I've got 50 miles per hour. That's the rate of the truck. So giant, big, fat mess is what it feels like. But I guarantee you, as messy as this seems, it will be easier if you organize things in kind of a grid like this. So make yourself a plane, an equation for the plane. Just remember, if initially you had rate and time of the plane, the problem just guided us through these equations that they wanted us to set up so that we could rephrase everything in terms of the truck. Then we could get our two equations in terms of the truck, isolate the letter we're after. You could also, as you get more experience at this, you could have isolated the time of the truck in both equations and gotten the rate of the truck that way. It's harder, believe it or not. If anything could be harder than what we just did, but you can get there in the end. Let me do one more. Not as big a pool of options to draw from here because I want to leave you guys some practice problems. Okay, so page 424, we've got 34, and we're dealing with boats here. The speed of a certain boat in still water is 24 miles an hour. So this boat, if left to its own devices, and let me get my sheet of paper here where I worked this thing out so I can refer myself to it. Now I've got about 5 more minutes, okay? You can go look for the clothes you want to wear. Okay, the speed of the boat in still water is 24 miles per hour. Now, if that boat can go 54 miles upstream, in the same time that it takes to go 90 miles downstream, find the speed of the current. So I wanted to do this problem. It's a classic distance equals rate times time problem. Notice that we only have one boat. This isn't like the last problem where we had a plane and a truck. We only have one boat. But it talks about what happens when the boat goes upstream versus downstream. Now, upstream, I'm going to rephrase that as not with, against the current. So in the first sentence, the boat was in still water. There was no current. For the rest of the problem, the current is going to be a factor with the current. So notice that downstream, it can make it a lot farther. Upstream, it's fighting the current. Okay, so it's like, is the current helping or hindering this boat? So I'm going to make my giant grid here, sort of expand everything else out. And my two rows will be upstream and downstream instead of boat or plane and truck. Upstream and downstream. So Speed of the boat in still water is 24 miles. Okay, so the distance upstream is 54. Equals the rate times the time. Notice that it takes the same time as going 90 miles downstream. So I'm going to leave the time variable the same. I'm not going to say time upstream, time downstream. I'm just going to leave it as time because it's the same time. And time is going to be our bridge between upstream and downstream. Okay, now in the current problems, here I tend to let R equal just the rate of the boat. Or speed of boat. And so we know that that is 24. And I let C be the speed of the current. Okay, so here's how this is going to work. If I'm going upstream, I have my 24 miles an hour that my boat can go, but I am fighting the current. Upstream, I need to actually subtract the current. The current is slowing me down. Me and the current are working against each other. If I'm going upstream, one equation down, I actually need to add the current because now the current is my friend. So what these equations are going to look like, equation 1, equation 2. So I have distance equals rate, that whole thing, those two rates combined times time. And okay, so our goal is to find C. I'm not sure, Matthew, I'll have to look. Have you found your clothes yet? I'm almost finished. It's difficult to isolate C, so we'll just focus on T. In the last problem, it was easier to isolate what we were actually focused on, but here, not really. So what I'm going to do is divide away my 24 minus C from equation 1. I don't need the parentheses down there. And in equation 2, I'm going to divide away my 24 plus C. Okay, so I have T, and I have T again. T always equals itself. So set those two things equal. Okay, fine. Find what you think is good clothes for today. Okay, and then cross multiply. And this is a case where even though we weren't able to isolate the letter we were looking for, it's actually going to work out better for us. Because, sorry, wheels are turning again, because we'll be left with the C for the current. Now, I can jump right into multiplying this out, but because this is a word problem, I want to take advantage of as many tricks as possible. Let me see, can I isolate here? I think these are both. Okay. I think these are both divisible by 9. 9 times 6 is 54. 9 times 10 is 90. That way, when it comes to distribution, I have smaller values. So let's see, 4 times 6 is 24. Is that 144? 240. I think that's right. I get when I have to multiply things horizontally, I always like to check vertically. I love multiplying vertically. Okay, the C's, I can collect them on the left. So that 10 will turn positive. I'll have a 16C. And then if I subtract the 144, again, being extremely obsessive about doing things, where I have 96. And let's see, is this going to come out?
I got these cards. I got these cards.
Oh, those are people on bicycles. Yeah. So this is going to be 6 miles per hour is what the current does. For better or for worse. Okay.
Which recording is it?
Oh, math recording. So that's what I've got for the distance problems. Again, I would encourage you to look at the example 5. Do not look at practice 5 unless you're just really wanting to try and figure it out like I was. That leaves you problems 31 and 33 to attempt, which are close enough to what I did. Of course, they're never identical. If you need more, let me know. I can dig into the back of the homework section. I think there's some more in there. Sometimes the more creative problems get shoved at the end, and we don't want these to be too creative, but I can look and find you more. I'm trying to give you the bare minimum, like here's what you need to accomplish the goal. Check the box on the distance equals rate times time problems for this section. That only leaves us 7.7, which is a few more word problems, but pretty mild. As whenever they stick word problem sections at the end of a chapter, I am most inclined to skip a lot of those because it's just too much. Nobody needs that. So let me go ahead and close this off and stop my recording and see if I can.